right, so for example number 3, we're going to do an initial value problem. So they give us dy dx, and it is x times the natural log of x. And the initial condition is y equals -1 when x equals 1. Now what that really means is that the point 1 comma -1 is on the curve. So when they give us a point, is that a particular or general solution?
I'm sorry, can you ask?
Particular or general solution when they give us a point?
Oh, particular.
Particular, right? What's the difference between particular and general?
One is specific and one's general.
Very good. But what do we see in the general solutions?
Oh, isn't that the lines?
Yeah, so the plus c represents the family of functions, right? You guys are all making hand movements. I wish I could record them on the video. It's fun. Did you do that again?
No.
Okay. So, yeah, we could have that vertical translation, and that's what the plus c represents, because the slope is the same. Remember, dy dx represents the slope. All right, so what does this mean? Well, to solve, what we want to find is y, right? We don't know what that is, so we have to solve. So to solve, we're going to take the antiderivative of the natural log of x times the natural log of x dx. So again, here we have a product. We have x times the natural log of x, so we could do integration by parts. When we do the integration by parts, I'm going to I suppose it doesn't matter, but I'm going to try something different. I'm going to let u be the natural log of x, and I'm going to change the notation from the textbook just a little bit, because you might see it differently. They use the Leibniz notation, but you might see prime notation, so I'm just going to interchange them.
Why are you trying to confuse us?
Not trying to, I'd rather confuse you now in the classroom than have you be confused if you take the test.
Yeet.
I'd rather we work that confusion stuff out now here in the classroom. Okay? But it means the same thing, right? U prime means du, right? So u prime of this is, everybody remembers this off the top of their head, right? The derivative of natural log of stuff is what?
The stuff.
1 over the stuff times the derivative of the stuff, which is just 1, right? So it's 1 over x times the derivative of x, right? And technically there's a dx that goes there, but we're using the different notation, so just remember that. So now the next thing is dv would have to be x, and that means that v would have to be, is it x squared over 2?
Yes.
Right? You guys, how good do you feel about doing those little simple antiderivatives with the power rule backwards? Yeah? Thumbs up if you do that in the shower when you wake up in the morning.
It's just like
shower at
knowing,
night.
it's just knowing the
Actually
little
does.
tricks like that.
Huh?
It's just like knowing the little, memorizing things.
Yeah, what I always do is I used to get this part screwed up, but then I take the derivative, and if I could take the derivative and get the, like, for example, if I toss the 2 to the front, 2 divided by 2 is 1, and then I subtract the 1 from the power and I get x. So that's what I do. So now this thing is just going to be u v minus the integral of v u prime. So that's what it looks like with prime notation. Normally, you would almost never see this prime notation with the integral. They almost always use Leibniz notation, but I have seen it in the past, especially if you go online and look up a practice study guide or something. So that's why I'm kind of going over this with you. So u is the natural log of x. V would be x squared over 2 minus the antiderivative of v, which is x squared over 2, and then u prime, of course, would be 1 times x. All right, and that's going to be with respect to x. So we'll put the dx in there. All right, so here's a cool thing. Notice that the x, 1x here cancels with 1x here. So really, I'm taking, it's the natural log of x times the quantity x squared all over 2 minus the integral of x over 2, right, dx. Well, that's helpful because in the next line I could say that's the natural log times x squared over 2 minus 1/2, toss the 1/2 to the front, and do a little something like that, right? Did I do that correct? Let me double check the book. Yeah, it looks good.
That sick beat though.
Yeah, I know.
The DJ's coming out of you.
So now when I take the antiderivative of this, I've got 1/2. The antiderivative of x we already know is going to be x squared over 2, right? And then all this stuff stays the same. So I've got the natural log of x squared over 2. Boom. Now at this point you can kind of leave it alone because you're done. I mean, you got, at some point you're going to do this plus c thing. Actually, we'll solve for c in a minute, right? So I might try to clean it up a little bit. I might say the natural log of x times x squared over 2 minus x squared over 4. I think that's how your textbook has it, right? Yeah, that's how they do it. Now, what did I just solve? Well, this is y equals this plus c. Now, because they gave us a point on the line at the beginning of the problem way up here, where x is equal to 1, y is equal to -1, I could solve for c by plugging those numbers in. So if I say -1 is equal to the natural log of 1 times 1 squared over 2 minus 1 squared over 4 plus c. All right. Somebody remember what the natural log of 1 is? I do. No? Yeah, the natural log of 1 is always going to be 0, so this whole thing goes away and becomes 0. So I got -1 is equal to 0, and this is just -1 over 4 plus c. So when I'm going to add 1/4 to this side, and I'm going to add 1/4 to this side. This becomes -3/4 is equal to c. So then my particular solution then would be y is equal to the natural log of x times the quantity x squared over 2 minus x squared over 4. Well, it's actually minus 3/4. Oops. And that's it. That's your answer. So for those of you playing along at home in the chairs there, let's do the old thumbs up. I'm an expert at this. Thumbs down. I can no longer take any more calculus. And if you're somewhere in between.